Did you know that the nucleotide sequence of DNA can be converted into music? In 1986, the Japanese geneticist Susumu Ono discovered DNA music by converting the nucleotide bases G, T, C, and A to the musical notes A, C, G, and D, respectively. This intriguing revelation led to the question, if DNA can be translated into music, can music, in turn, affect or change our DNA? Sound, as we now know, possesses mass and has the ability to move matter. By delving into the study of cymatics and exploring the potential effects of music on DNA, we can begin to uncover the possibility of utilizing music as a healing tool. Susumu Ono's groundbreaking research in translating DNA sequences into melodious compositions opened a door to a realm of unexplored possibilities. By associating specific musical notes with nucleotide bases, Ono revealed the inherent musicality encoded within our genetic blueprint. This discovery not only ignited fascination, but also prompted profound questions about the reciprocal relationship between DNA and music. If DNA, the fundamental blueprint of life, can be transformed into music, what potential influence could music have on our genetic code? Ono's approach of converting DNA into harmonious melodies highlighted the underlying connection between the complex language of genetics and the universal language of music. DNA, consisting of 4 nucleotide bases, adenine, A, cytosine, C, guanine, G, and thymine, T, can be seen as a symphony of genetic information. Each base holds a distinct role in determining the genetic instructions that shape an organism. By associating musical notes with these nucleotide bases, Ono unveiled a profound interplay between the scientific and artistic domains. The translation process not only created beautiful compositions, but also provided insights into the inherent musicality within our genetic code. This revelation sparked a deep curiosity about the reciprocal relationship between DNA and music, whether music, in turn, could influence or impact our genetic makeup. Considering the intricate nature of DNA and the complexity of musical compositions, one might ponder the potential effects music could have on our genetic code. Music has a pathological responses in individuals. It can ignite joy, calmness, excitement, or introspection, transcending language and cultural barriers. If music has the ability to affect our emotions and well-being, could it also have a tangible impact on our DNA? While scientific evidence in this area is still emerging, preliminary studies suggest that music may indeed have the potential to influence genetic expression and cellular processes. The field of epigenetics explores the factors beyond DNA sequence that can influence gene expression. It acknowledges that external factors, such as environmental stimuli and lifestyle choices, can modify the way genes are expressed. The field of cymatics offers a captivating perspective on the relationship between sound, vibrations, and the formation of intricate geometric patterns in various substances. By studying the visual representations of sound waves in materials like sand or water, researchers have made remarkable discoveries about the vibrational energy emitted by sound. This exploration
from the sun is unpolarized, which means the electric fields of the light are all randomly oriented, oscillating back and forth equally in all directions. But it just so happens that when the light in the rainbow ray reflects off the back of the droplet, it does so very close to a special angle known as Brewster's angle. At this angle, all light with its electric field oriented parallel to the plane of reflection is transmitted. So it passes out the back of the droplet. And therefore, the only light that is reflected has its electric field perpendicular to the plane of reflection. This is the light that creates the rainbow. This means rainbow light is polarized along the direction of the rainbow, so horizontal at the top and closer to vertical on the sides. This is why you can use a polarizing filter to make a rainbow disappear. To make it brighter if you orient the filter to allow that polarized light to pass through.
Into the realm of cymatics raises intriguing questions about the potential impact of music, which consists of complex sound waves on the human body, including our DNA. Cymatics has revealed that specific sound frequencies can generate mesmerizing patterns in matter. As sound waves travel through a medium, they cause the particles within that medium to vibrate. These vibrations, when organized and coordinated, manifest as intricate geometric shapes that can be observed and studied. The notion that sound waves have the power to visibly change matter leads us to consider the possibility that music, with its rich and intricate collection of sound waves, may possess the ability to influence not only our physical surroundings, but also the very essence of our being, our DNA. When we listen to music, we experience a symphony of different frequencies and harmonies. Each musical note corresponds to a specific frequency and wavelength, creating a complex tapestry of sound. These musical vibrations, just like any other sound waves, have the potential to interact with our bodies at a fundamental level. Within our bodies, DNA serves as the blueprint for life, containing the genetic instructions that shape who we are. It is composed of nucleotide bases, and each base has its own vibrational properties. Given that sound waves can affect the vibrational patterns in matter, it is not far-fetched to hypothesize that music, as a collection of intricate sound waves, might influence the vibrational state of our DNA. The potential influence of music on DNA brings to mind the concept of resonance. Resonance occurs when two objects share similar frequencies, causing one object to vibrate in response to the vibrations of the other. It is possible that the resonant frequencies present in music could interact with the vibrational frequencies of our DNA, creating a harmonious resonance within our cells. If music has the power to influence the vibrational state of our DNA, it could potentially impact gene expression, cellular processes, and ultimately, our overall well-being. This opens up a new realm of possibilities for utilizing music as a therapeutic tool, capable of restoring balance and promoting healing at a fundamental level. The exploration of sound and vibration on the human body has been the subject of numerous studies. One fascinating area of investigation is sound therapy, which has demonstrated its ability to promote relaxation, reduce stress, and enhance overall well-being. It has been observed that the resonant frequencies emitted by various musical instruments can stimulate different physiological responses in individuals, highlighting the profound influence that sound and vibration can have on our bodies. When considering the impact of sound and vibration on DNA, it is crucial to recognize that DNA is not simply an inert molecule. Rather, it possesses inherent vibrational frequencies that contribute to its functioning. These frequencies play a crucial role in the stability and integrity of our genetic material. Disruptions or disturbances to these frequencies can lead to genetic mutations or alterations, which can have significant consequences for our health and well-being.
Is the color green. It's the heart of the rainbow. That's the miracle note from the original solfeggio note, from the original solfeggio scale. And the other note that you see, 741, which is part of nature, is called the devil's interval in musicology. 741 with 528. It creates such an annoying and dissonant energy, diseasing, stressful, that if you continue to listen to it, you could die.
But even when rainbows are visible, you can turn them invisible using sunglasses. That is, as long as they are polarized.
There's a simple experiment in physics almost no one talks about after high school. It's called the double slit experiment. At first, it sounds harmless. A few particles, a few slits, some dots on a wall. But the closer you look, the more unsettling it gets. Particles seem to know when they're being watched. Reality seems to change, just because something could have known what happened. And if that's true, and according to physics it is, what even is reality without someone there to witness it? What clicked? What if the final missing? And if that's true, and according to physics it is, what even is reality without someone there to witness it? When I heard real physicists hinting that consciousness itself might be woven into the fabric of physics, something clicked. What if the final missing link in the theory of everything isn't hidden in space, or the universe, or time, or particles, but within us? If that idea sounds impossible or ridiculous, well, stay with me.